Hello guys, in this video I am going to solve this question number 49 from chapter 7 Capacitor and Inductor of books Engineering Circuit Analysis by Hayt, Kemmerly and Durbin. The question is that for this particular circuit we need to, if it is assumed that all the sources in the circuit has been connected and operating for a very long time. So this is a very this you need to note that the circuit is in this state for a very long time, and for this we need to use the superposition theorem to find the value of VCT and VLT. VCT means this voltage and VLT the voltage across the inductor. So as it is mentioned in the question that the circuit is in this position for a very long time, so it means that for a constant sources, for this and this sources, when this sources, for this sources, the impact of this capacitor and inductor will not be there. Means for this sources, like we know that for a constant sources, our capacitor will be replaced with open circuit and inductor by closed circuit. Why? Because we know that our expression, it is like for this current, it is C dV by dt. For the capacitor the relation is this. So since if the sources are constant, then the dV by dt will be constant, and means it will be 0. So if voltage across the capacitor is constant, if the source is constant, voltage will be constant, and if voltage is constant, then this term it will be 0, and it means the current will be 0. If current is 0, it means the capacitor can be replaced with the open circuit. Similarly, for the for this L, we know that V is equals to L di by dt. Right, over here we know that since the sources are constant, so if it is constant, then this term it will be 0, and if it is 0, then it means V is 0. If V is 0, now for a short circuit, like if the connection is short circuit, then since over here resistance is 0, so voltage will be 0, or if current is 0, then voltage will be 0. Now over here since current is not 0, current is constant, right? And since current is constant, so this situation is not there. So situation is this. So over here R is 0. R is 0 means that we can replace the inductor with a short circuit. So it means we can replace the inductor with a short circuit. So if the sources is constant, then we can replace the capacitor with the open circuit and inductor with a closed circuit. But we cannot do the same thing for the if the sources is varying, like for this one. For this we cannot replace the capacitor with the open circuit and inductor with closed circuit, right? So since over here we need to solve it with the superposition theorem, so let's see how we can do that. For the superposition theorem, we know that as per the superposition theorem, we need to consider all the sources one by one. So we will consider, like over here we have 3 sources, right? This and this. So we need to draw 3 circuits, right? We need to draw 3 circuits. So let me first consider the 3 milliampere. So for this circuit, since it is a constant source, so since it is constant, so our capacitor it will be replaced with open circuit and inductor will be replaced with short circuit. So our initial circuit, like it will be, since I consider only this one, it is 30 milliampere, right? Over here let me let me put a capacitor. This is inductor, this is okay. We also have this one, right? So we have 4 sources. So now this voltage source, as per superposition, all the voltage sources will be replaced with a short circuit and current sources will be replaced with open circuit. So this voltage source will be replaced with short circuit, right? Like this. And this is a current source, so it will be replaced with open circuit, right? This current source will also be replaced with open circuit. So my circuit will look something like this. Now over here, since it is a constant source, so our capacitor, this, it will also be replaced with open circuit. It will be open, right? This inductor, it will be replaced with short circuit. So I will replace this. It is this. So this is my circuit, right? And in this circuit we just have a single resistor. Now if I redraw this circuit, then this can be removed. This is open, this can also be removed, right? This is open, this can also be removed. So I just have this thing. It is 20 ohm and this is 30 milliampere. So I just have this thing, right? Now over here the question is, so as per the question, what we need to determine? We need to determine the voltage across the capacitor and the inductor, right? So over here, since means VL is over here, this part, VC is over here. So since VL is short circuited, so for this particular circuit, our VL, it will be 0 volt, right? And then what is VC? Our VC is over here. So it is simply like VC is over here, VC. And polarity, it is given as plus over here, minus over here. So plus minus. Now what is our VC? Our VC will be the voltage drop across this 20 ohm. So VC is equals to voltage drop across 20 ohm, means it will be this IS, this I into 20, right? So this is the current with plus and minus. So it will be 30 milliampere, means 30 into minus 3 into 20, right? So it will be, if you solve, you will get 600 into 10 power minus 3, means it will be 0.6 volt. So this is VC dash, right? VC dash. So this is our this, and our VL dash, this is VL dash is 0 volt. So it means that for this current source, our VL dash is 0 and VC dash, the voltage across the capacitor, it is 0.6 volt. Now similarly, now after this, now I will consider another source as active. I will keep this as active and I will just remove all the other sources. So I will replace this with open circuit, this will open circuit, this will open circuit. So since everything will be open circuit and we just have the constant source, and because of the constant source, again the inductor will be short circuit, capacitor will be open circuit. So our circuit, like after deactivating the current and the voltage sources, means just keeping this as active, so deactivating all the current sources, my circuit, it will be something like this. This is capacitor, this is, and this is our battery, this is 9 volt, and over here this is this, right? This is plus minus VC and this is 20 ohm. Now again you can see, after this we can remove the capacitor and the inductor, right? Because it is a constant source. So our circuit, it will look something like it will simply be this will be replaced with a short circuit, right? This capacitor, it will be replaced with open circuit, right? So now you can see, our this particular circuit, it is open from everywhere, right? It is open, like it is open from here, it is open from here, it is open from here, it is open from here. So this 9 volt, as such 9 volt battery will the current through 9 volt battery will not be there, because there is no closed path. And since there is no closed path, I in the circuit current will be 0, and it means that over here it means that our VL, it will be 0. VL dash double dash, it will be 0 volt. Why 0? Because still it is short circuited, so the voltage across the short circuit, it is always 0. And what is the voltage across VC? Now you can, if you look at this circuit, at this part, now over here this VC, the capacitor is directly, like it is in parallel with the 9 volt battery. Since current flowing through the 20 ohm, it is 0, right? So there will not be any voltage drop across 20 ohm. So overall VC double dash, it will be equals to 9 volt, right? So the voltage across the capacitor, because of the 9 volt, it is 9 volt, whereas VL double dash, it is 0 volt due to the 9 volt. Now considering the third case, now let's take this as active. Now if I take this as active, so our circuit, it will be let me draw this circuit over here, or let me erase this one. So this will be open, so my circuit, it will be right, this will be open, this voltage source will be short circuited, this is the capacitor, and this will be open circuit. So only one current source will be there, which is 20 milliampere, right? This is 20 ohm. Now our capacitor, it is going to be, because it is a current source which is constant, so our capacitor will be replaced with the open circuit, and similarly inductor will be replaced with short circuit. Now again, since inductor is short circuited, so for this our VL triple dash, it will be 0 volt, right? Now all the current will flow through 20 ohm, so 20 ohm like this, plus minus, so the voltage at VC dash triple dash, it will be equals to minus of 20i. Why minus? Because the polarity, like it is plus minus, right, and it is minus to plus, so the polarity is going to change, so it will be minus 20i. So we will simply write minus 20 into 20 milliamperes, so it will be equals to minus of 0.4 volt. So our VC triple dash, the voltage across the capacitor due to this 20 milliampere, it is minus 0.4 volt. Now coming to the last case, which is due to this voltage, due to this current source, which is varying, right? And since it is varying, so as we have mentioned over here, that if the current or the voltage source is varying with respect to time, then we cannot replace the capacitor with the open circuit and inductor with the closed circuit. We need to keep our capacitor and inductor as it is, right? So over here, just if we are using the superposition theorem, if only this source is active and all the remaining sources, this and this are deactive, then our circuit, it will be like this. This current source will be open then we have this is 20 ohm, this is 60 mH, right? Then over here we have a capacitor, then we have this which is short circuited, we have this current source which is 40 cos 10 power 3 t milliamperes, right? And over here this current source will be deactivated, means it will be replaced with the open circuit. So now we have this circuit, right? And for this circuit, let me put the capacitor value also. It is plus minus 5 microfarad, right? Now for this particular circuit, we can remove this, so if I remove this, just to like give a better look to my circuit, so my circuit will look like this, right? My circuit will just a minute, this will be replaced with, yes, it will be like this, open circuit. Now over here you can see that all the current, since we have a short circuit path, so the current through this because of this current source, like it will flow over here, like let it be is, right? So this is will flow over here, and at this node the current will try to get divided, but since we have a short circuit path, so all the current like this is, it will flow through the short circuit path, and the current through the capacitor, it will be 0, right? So there will not be any current flowing through the 20 ohm and through the capacitor, right? And since current is not there, so it means what will be the voltage? Like we know the voltage, like the formula for the current through the capacitor, it is I equals to C dV by dt, right? Now voltage, it is expressed as integration of I dt, right? Now since I is 0, it means that our voltage across the capacitor, it will be 0 volt. It means that VC4 dash, it will be 0 volt. So the voltage across the capacitor due to this current source, it will be 0. Why 0? Because of this short circuit path, right? Now what is the voltage across the inductor? Now the voltage across the inductor, it will be like, simply we have a loop, right? We just have a loop, and the current flowing through this inductor, it is is, means this. So the voltage, we know that the voltage across the inductor, it is given by L di L by dt, means the differentiation of the current flowing through the inductor. So what is our L? It is 60 into 10 power minus 3, it is given over here, right? Then differentiation of I3. What is I3? IL. What is IL? IL is the is, the current flowing through the inductor. So it will be the differentiation of 40 cos 10 3 t into milliampere. So we need to convert it into ampere, so it is this. Now solving this, now if I differentiate this, so over here this 40 and 10 power minus 3, they are the constants, so I can bring it out of the differentiation. So it will be 60 into 10 power minus 3 into 40 into 10 power minus 3 into differentiation of cos 10 power 3 t. Now the differentiation of cos, it will be like, it will be just a minute. Yes, so it will be like this term. It can be written as like it is 2400 into 10 power minus 6, right? Into differentiation of cos, it will be sine 10 power 3t into differentiation of this term, so it is 10 3t, 10 power 3, right? Now we will get like this 10 power 3 and this will cancel out, so we left with 3, and this means it is 2.4 sine 10 power 3 t. So it is our VL 4 dash. So you can see now if I compile, now our V dash V1 L, it is 0. Our VC single dash, it is 0.6. Then VL double dash, the VL double dash. So where we have VL double dash? Oh, yes, it is over here. So VL double dash is 0 and VC, it is VC. So VC double dash, it is 9 volt. So again writing it over here, it is 0 and VC double dash, it is 9 volt. Now third one, in the third case it is this, like our VC triple dash, it is 0.4, and over here we had determined that it is 0 volt because of the short circuit, right? So our VL triple dash, it is 0 volt, and VC triple dash, it is minus 0.4 volt, and now VL 4 dash, it is equals to, like over here we get this VL 4 dash is 2.4 sine 10 power 3t, whereas VC 4 dash, it is 0 volt. So we will write this. So VC 4 dash, it is 0 volt, and VL 4 dash, it is 2.4 sine 10 power 3 t, right? And now as per superposition, we are going to VL, it will be equals to VL single dash plus VL double dash plus VL triple dash plus VL 4 dash. Similarly, our VC, it will be equal to VC dash plus VC double dash plus VC triple dash plus VC 4 dash. So now substituting the value, we have this 0 0 0 and this, so overall VL, it will be 2.4 sine 10 power 3 t, whereas our VC, it will be like it is 0.6 plus 9 minus 0.4 plus 0, so I get 9.2 volt. VC is 9.2 volt, right? So this is the answer to this question, that the voltage, like coming back to the circuit is this, and it is asked that what will be the value of VCT and VLT. So our VCT, it will be 9.2 volt, and VLT, it will be 2.4 into 10 power 2.4 sine 10 power 3t. So this is answer to this particular question. So with this, I end this video. If you have any doubt, you can put it in the comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.